Jai Hind everyone. I am Vivek Kumar Pansari, Assistant Professor in Department of Mechanical Engineering at Akgec Engineering College, Ghaziabad. So, in the lecture series of Engineering Mechanics, I am covering the topic shear force and bending moment. And 2 lectures I have already taken for this particular topic, in which I discussed about beam, various types of load, various types of supports, how to find out support reactions in different beam conditions, and along with this I have also discussed the topic the statically determinate and statically indeterminate beam. Some problems I have already taken in this regard for finding out the support reactions. Okay, how to find out support reactions for different support condition and different loading conditions. So, if anyone is not clear about these particular topics, so please go through the previous 2 videos in which you will be able to understand definitely about how to find out support reactions. Now, today in this particular lecture, I am going to cover the shear force and bending moment. Shear force and bending moment, and definitely I assure you that you will get a feel what exactly the shear force and bending moment is, and how to find out the shear force, how to draw the shear force and bending moment diagram for different loading condition in different beams. So, continue watching this particular lecture series for getting the information, getting the knowledge about shear force and bending moment. Okay, so in this particular lecture also I am going to cover the concept of shear force and bending moment, what basically it is. When a beam is loaded, definitely it is loaded by certain loads, and against all these loads certain support reactions will be developed. Okay, so these are the external causes, these are the external effects which a beam has to support, and it will be supported in the manner of shear force and bending moment. So, these external causes for which the internal resistance which a beam material is offering, this is what the shear force and bending moment. So, shear force and bending moment already discussed in my previous 2 lectures also. Again I am coming to that particular point, whenever a beam is loaded due to different kind of loads, it offers certain resistance against these loads, and these internal resistances offered by beam material and beam cross section is known as shear force and bending moment. Okay, that is what I already discussed. If the load is parallel to the transverse plane, it means it is causing the shearing. This is what known as shear force. The another effect which a load can create on that particular beam, that is what the bending. It can bend also, it can bend the beam also. So, these 2 aspects we are going to discuss today. Okay. So, let us take a look about the beam. Here you can get an idea about, this is the overhanging beam which is subjected to load P1, P2, P3, and there are 2 reactions where R1 and R2 2 reactions. So, here I am taking one particular section AA at a certain distance from support R1. So, what is basically the shear forces? What I am trying to explain here, if I am taking all the loads on the either side of the section plane, what is the meaning of either side of the section plane? Either on the left side of the section plane or on the right side of the section plane. On the left side of the section plane, what are the different forces? P1 downward, P2 downward, R1 that is the support reaction against the load. So, this is upward. So, I am taking the algebraic sum of all these forces. If the algebraic sum is represented by this dotted force F, so this is what the resultant of P1, P2 and R1. So, obviously at this section plane F1 is the upward force. So, for the equilibrium of the beam on the other side of the section plane, there must be equal and opposite downward force which is parallel to the transverse plane, That is why it is named as shear force, and that force is known as, that force F is known as shear force. So that's what written here. Consider the beam as shown in figure, which is supporting the loads P1, P2, P3 and is simply supported at 2 points, creating the reactions R1 and R2. Take a section AA, already explained. Okay. Now let's assume that the resultant loads, resultant of what, P1, P2 and R1 has been taken, and the resultant is F, which is vertically upward. And since the entire beam remains in equilibrium, thus the resultant of the forces to the right of AA must also be F, acting downward. So on the one side of the section plane, it is upward. On the other side of the section plane, it is downward. So obviously it will cause the shearing. All these forces are parallel to the transverse plane. That's why it is named as shear, and these equal and opposite forces will try to create the shearing action. That's why it is named as shear force. Okay. So this force F is a shear force, okay, at any section X. How to find out it? It is written over here. At any section X of the beam, the shear force F is the algebraic sum, which we have already taken here. Algebraic sum of what? P1, P2 and R1. So this is what we have taken. So algebraic sum of all the forces acting either side of the section plane. Now come to the point. What sign convention we have to follow? Okay. In last lecture also slightly I covered regarding this. So if on the left side, we are finding that the algebraic sum of all the forces is upward, or on the right side of the section plane, algebraic sum of all the forces is downward, both will produce the same effect. So that's why both of these will be considered as positive shear force. Vice versa of this is also true. If on the left side of the section plane, the resultant of all the forces is downward, or on the right side, resultant of all the forces is upward, this will be treated as negative shear force. So that's what the first thing which must be known to us. Okay. So shear force, algebraic sum of all the forces acting either side of the section plane. Sign convention, left side of the section plane, upward shear force positive, right side downward will be positive, and vice versa. Now come to the point, bending moment. So again I am considering the same beam. Again I am taking the same load P1, P2, P3, and because of them the reactions are R1 and R2. Okay. I am considering a section A. Now because of all these loads P1, P2 and R1, which are on the left side of the section plane, I am taking the algebraic sum of moments, which is represented by this dotted line. Okay. So the moment, algebraic sum of all the moments due to various loads. So P1, P2 and R1, because of all these. Okay. For the equilibrium of the beam at section A, on the right side, there must be equal and opposite moment also. For the equilibrium of the section, for the equilibrium at the section of the beam. So what it will do? Definitely it will try to bend equal and opposite moment on the either side of the section plane. So it will not rotate, it will try to bend that particular beam. Okay. So this is what known as bending moment. Okay. Bending moment. So the resultant moment about the section A of all the loads and reactions to the left of the X section A is clockwise. This is what we are observing here. Okay. And then the moment of forces on the right side AA must be counterclockwise for the equilibrium, and this is what known as bending moment. So then M is called the bending moment because it is trying to bend at that particular section. It is trying to bend the beam at that particular section. That's why it is named as bending moment and abbreviated as bending moment. So what basically the bending moment is? Bending moment, it is the algebraic sum of all the moments about an X section of all the forces acting on either side. So whatever the number of forces, जितने भी forces हैं उन सारे forces की वजह से continue जो भी आपका moment create होगा on the either side, either on the left side or on the right side of the section plane. Okay. So, I hope this thing is now well understood ki what basically the shear force is and what basically the bending moment is. Shear force, I am again repeating, it is the algebraic sum of all the forces acting either side of the section plane, and sign convention for it is on the left side of the section plane, if the resultant of all the forces is upward, it will be considered as positive. On the right side, the opposite of this for the equilibrium purpose. Okay. So, on the right side, if the resultant is downward, then it will be considered as shear force, because both will produce like a scissor. If one arm of scissor is going down, another one is coming up, it will produce the same effect. So, the same effect will be produced by these two forces. Similarly, I can say bending moment, it is the algebraic sum of all the moments acting either side of the section plane. So, obviously, on the left side, if it is clockwise, on the right side of the section plane, it will be counterclockwise, and it will produce no other effect than the bending at that particular section. Now, coming to the sign convention. Sign convention for bending moment, on the left side of the section plane, clockwise will be considered as positive. So, similarly, on the right side, the counterclockwise or anti-clockwise will be considered as positive. And which type of effect it will be producing? It will be producing the sagging moment. And hogging on the other side, if on the left side it is anti-clockwise, on the right side it is clockwise. So, it will be producing what? It will be producing the convex surface towards, okay, convex surface. This is what the convex surface, here we are finding the concave surface. Okay. So, this will be treated as negative and this will be treated as positive. It will be treated as positive. So, I hope up to this point, because all these points are necessary to understand when we are going to draw the what? Shear force and bending moment diagrams. So, this is clear. Now, we can prove whatever I said in terms of P1, P2, P3, that we can justify with the help of numerical also. So, now let us take a beam, let it get. Okay. I am putting a roller support here. I hope it is visible. Those who are present in the lecture, if they are not able to see the diagram, they can write. Okay. All these loads are 10 kilonewton, 10 kilonewton and 10 kilonewton, sorry, 10 kilonewton, let me write. Okay. The distances are 1 meter, 1 meter, 1 meter. What I am trying to justify here, so whatever I said, that it is the algebraic sum of all the forces or all the moments. So, that is what I am trying to justify here with the some numerical data AB. Okay. So, which type of beam it is? It is, I hope it is clear to everyone now. It is supported at ends by roller and hinge support. So, I can say this is what the simply supported beam. What are the type of loads? Type of loads are clearly known to us: 10 kilonewton, 10 kilonewton, 10 kilonewton. Okay. So, can we find out the support reaction? Okay. Students, those who are available in the live lecture, they can write the answer ki what will be the support reaction for this. Very simple one. We have already gone through two difficult type of problems. Okay. Anyone? Anyone who can write, who can find out the support reaction here? No. Okay. Sorry. By the symmetry, I can say it will be 15 kilonewton. It will be 15 kilonewton. Total load कितना है भाई? Total load है 10, 10, 10, 30, equally distributed. Okay. So, 15 kilonewton, 15 kilonewton. Now, as the previous example, I am taking what? I am taking a section. Section 1, 1 I can take. Distance, what should I take? Okay. Any distance may I take? So, I am taking the distance from this point, it is 0.75 meters. Okay. 0.75 meters from here. Now, what I am trying to justify here, on the left side of the section plane, on the left side of the section plane, on left side of section 1 1. What are the forces? Take the algebraic sum of all the forces. 15 upward, 10 downward. So what we are finding out? What we are finding out? We are finding out it is plus 5 kilonewton, which is upward. Okay. Now coming to the right side, on right side of section 1 1. What are the forces? Minus 10 plus 15. What it will be? What it will be? Minus 5 downward. This is what the resultant of force is. I am not saying it is a shear force. Okay. So it is, 5 kilonewton here, 5 kilonewton here. Okay. What these two forces will do? These are the resultant forces on the left and on the right side. 5 upward, 5 downward, 5 upward and 5 downward. So that's why I said it is the algebraic sum of all the forces acting either side of the section plane, and these two forces will try to shear at that particular section 1 1. So that's why these are named as shear force. Okay. And according to our sign convention, both will be considered as positive shear force, because both these forces, either it is upward on the left side or downward on the right side. Okay. So both are producing the same effect at the section. Similarly, for this is for shear force, and now I am coming for the bending moment. Okay. Take the algebraic sum of all the moments acting either side of the section plane. Okay. Okay, let me write the equation on the section plane 1 1. Okay, what it will be? 15 into, what is the distance? 1.75. Then from 10 kilonewton, and it is creating the clockwise. This 10 kilonewton, it is creating the anti-clockwise movement. So minus 10 into 0.75. How much it will be? How much it will be? Just calculate. Those who are available in the lecture, please calculate. 15 into 1.75 minus 10 into 0.75. How much it is? It is coming out 18.75 kilonewton meter, and the direction will be clockwise. Okay. It is for the left side of the section plane. On the right side of the section plane, now come to this. This 15, how far it is from section plane? It is 2.25. So 15 into 2.25. Then I am coming to this one. Okay. Minus 10 into 1.25. Then I am coming to this 10. This is on the right side. Minus 10 into 0.25. How much it is coming? What is the answer? Please tell me the answer, those who are available in lecture, please. Okay. What is the answer? I think it is 18.75 kilonewton meter, and the direction is this, anti-clockwise. Okay. So what we are observing? If this is a beam, this is a section. On the left side, it is 18.75. On the right side, it is 18.75. What it will try to do with the beam at this particular section? It will try to bend it. So mathematically also we can say it is the algebraic sum of all the moments acting either side of the section plane. Similarly, for the shear force also, again I am explaining here. This is our section plane. This is +5, this is 5 kilonewton upward on the left side. This is 5 kilonewton on the right side. So what it will try? It will try to create a shearing action at this particular section plane in the beam. So this is what the shear force and bending moment. Okay, why I am emphasizing on this? Because for doing the questions we have to write these kind of equations only. That's why I am emphasizing. Why I am emphasizing on this particular sign convention? Because if we are not knowing the sign convention, then definitely we will not be able to understand in which direction our curve is going. So that's why I am emphasizing on this particular. Okay. So shear force, bending moment. This is clear. Now I am coming to the basic relation between the shear force and bending moment, because without this we will not be able to draw the what? The shear force and bending moment diagram. Okay. So basic relation, the relation between shear force and bending moment. I hope these two terms are clear. What is shear force? What is bending moment? Okay. And sign conventions are also clear. If anyone is having doubt, please write in chat box कि sir this is the doubt. यहाँ पर doubt है. I am not getting the definition of shear force. I am not getting the sign convention. I am not getting the bending moment. Okay. Then because उसके बाद ही हम question properly solve कर पाएंगे. Okay. I hope if no one is raising any point, it is clear to everyone. So relation between shear force and bending moment. So here I am taking a simply supported beam in which the load is varying with a constant slope. Okay. So it's a UBL, and from point X, from point A, it is at X distance. I have taken a small element. This is the small element I have taken of dx length. Okay. So the distance from here to here is dx. Okay. What are the forces? What are the forces, shear forces and bending moments? Okay. So from the origin I can say, थोड़ा सा इसको enlarge कर दिया. Okay. This particular, the orange section is enlarged here. So it is at x distance, dx element, it's a very small one. So I am considering it as a UDL. So if I am considering it as a UDL, it will be W delta x, which will be in the midpoint of delta x distance. On the left side of this particular element, the load element which I am considering, on the left side, the F is the shear force, M is the bending moment. On the right side, F plus delta F is the shear force and M plus delta M is the bending moment on the right side. Okay. So now I hope the picture is clear, the diagram is clear. For finding out the relation between shear force and bending moment, I am considering a variable load in which a very small element of dx length has been considered, which is at x distance from the origin or from the point A. On the left side of this dx element, the F is the shear force, M is the bending moment. On the right side of the dx element, the F plus delta F is the shear force and M plus delta M is the bending moment. Okay, up to this point. So this is what the construction of the shear force bending moment diagram is greatly simplified if the relationship among load, shear force and bending moment is established. So that's what I am saying. If without knowing the relation, we will not be able to draw the particular SFD and BMD. So that's what already explained. Let's consider a simply supported beam AB carrying a uniformly varying load of W per unit length. So this is what already explained. Now I am coming to the free body diagram. So free body diagram already taken care. What are the different forces? F, M, W delta x, F plus delta F, M plus delta M. Okay. So the forces acting on the free body diagram of the detached portion of this loaded beam are the following. The shearing force F and F plus delta F at x and x plus delta x respectively. The bending moment at section x and x plus delta x be the M and M plus delta M. Force due to external loading, if W is the mean rate of the loading per unit length, because this element is very small, so that's why we are considering as a UDL. So W delta x for that particular section. For which section? For this particular section, W delta x. very small length. So I am considering that there is no variation in delta x. So that's what we have taken here. Okay. So these are the forces and moments. This small element must be in equilibrium under the action of these forces and couples. Okay. This is what we are doing. Now let's take the moment at point C. What is the point C? Where is the point C? Let me come. The point C, the center point of dx element. So let's write the equation. Here is the equation. Moment about point C, m, which was on the left side. I will go at that particular diagram. M, f delta x by 2 plus f plus delta f delta x by 2 equal to m plus delta m. Let's have a look there. What are these? Whatever I am saying, क्या यही है? On the left side, कहाँ ले रहा हूँ moment at the point C, m. Okay, this is the one. F, how far it is from point C? So f into delta x by 2. Then I am reaching to f plus delta f. How far it is from point C? So the force f plus delta f, distance from point C, it is delta x by 2. So f plus delta f into delta x by 2. All these are clockwise, m clockwise. Because of this f at point C, the direction of moment, rotational tendency clockwise. Because of this f plus delta f, the rotational tendency, f plus delta f into delta x by 2, this will be clockwise, and m plus delta m is the anti-clockwise. So this is what I am saying here. So this is the equation. Now simplify this particular equation and ignore the smaller quantities. Okay, so m cancel हो गया, f delta x by 2, f delta x by 2, f plus delta f x by 2, ये equation हमारा आ गया इस तरीके से. Okay, so f delta x by 2, m getting cancel, f plus delta f into delta x by 2 equal to delta m. Delta f and delta x both are smaller quantities, so after multiplication will become more small, so neglect कर दिया. So f delta x ये हमारा हो गया f delta x equals to delta m, and the relation is coming out f equal to delta m over delta x. Under the limits, when delta x is reaching to the 0, tending towards 0, f equal to delta m over dm over dx. So there is a differential relation between shear force and bending moment, f equal to dm over dx, f equal to dm over dx. This point is clear. Now I am resolving all the forces vertically, So what are the forces? I know f on the left side, f plus delta f on the right side, and w delta x. These are the forces at that particular element. So w delta x downward है, f plus delta f downward है. We can go through the diagram. We can come, f upward है, w delta x is downward, f plus delta f is also downward. Okay, so w delta x plus f plus delta f equal to f. So w equal to minus df over dx. Under the limits, this is coming out, w equal to df over dx, and for f I can write dm over dx. So it will be w equal to minus df over dx d square m over dx square. So this is the relation between shear force and bending moment. So this can be one of the questions. Sometimes the relation between shear force and bending moment is asked in exam for 2 marks, for 3 marks. It can be a question for 2-3 marks. Okay, so I hope the terms are clear, the things are clear. Okay, now what we can conclude from this? What is the basic conclusion we can establish with this? First thing, from the above relation, the important conclusions can be drawn from the equation 1. What is the equation 1 here? The equation 1, f equal to dm over dx. What we are observing here? F equal to dm over dx. Let me write this. F equal to dm over dx. So what can I write? F into dx equals to dm. What basically it is? F dx. This is what the area of shear force diagram between 2 points, which is equal to what? Which is equals to change in bending moment between these 2 points. M equal to F dx. If I am integrating it, so the slope of bending moment diagram is the shear force. This is clear. This is very clear. This is from the relation itself. It is clear. F equal to dm over dx. So the slope of bending moment diagram is the shear force, and F equal to dm over dx. If F equal to 0, the slope of bending moment diagram is 0. The bending moment is therefore constant. So the 2 or 3 conclusions. One conclusion already there. Second conclusion, the slope of bending moment diagram is the shear force. This is clear. Now I am coming to the third conclusion. Dm over dx equals to 0. Dm over dx equal to 0. What it is? If dm over dx equal to 0, it means it is the condition of maxima or minima. It is the condition of maxima or minima. So at that particular point where shear force is 0, where bending moment will be either maximum or minimum. So these are the certain conclusions we can draw from that particular equation, F equal to dm over dx. The area of shear force diagram between any 2 points from the basic calculus is the change in bending moment, F equal to dm over dx. So this is clear. F equal to dm over dx, this shows the slope of bending moment diagram is shear force. If at particular point F is 0, it means the dm over dx equal to 0. So the maximum or minimum bending moment occurs here, because according to the calculus, this is the condition of maxima or minima. I hope there will be no confusion in this. There is no confusion. 2-3 conclusions we are drawing from here. Okay. Another thing, the point of contraflexure and point of inflection. What it is? अभी हमने point define किया, the point where shear force is 0. That point is maximum bending moment or minimum bending moment at that particular point. Bending moment भी तो 0 हो सकता है. So the point where bending moment is changing its direction. The point where bending moment is changing its direction. What does it mean? From positive to negative, from negative to positive, because we are getting two nature, positive, negative. Okay, it can be a sagging or hogging. Yes or no? Positive, negative. If on the left side it is clockwise, positive. If on the left side it is anti-clockwise, it is negative. So according to that, it can be a positive and negative, or it can be a sagging or hogging. So obviously, so the point where bending moment diagram is changing its nature, from positive to negative, from sagging to hogging, from concavity to convexity. That particular point is known as point of contraflexure. That particular point is known as point of contraflexure. It is not the point where shear force is 0. It is the point where bending moment is 0. So the point where mathematically it is the point where bending moment is 0, or I can say technically where the bending moment changing its nature, or from sagging to hogging, or vice versa. So that particular point is known as point of contraflexure. Clear? Point of contraflexure क्या point है? Mathematically it is that point where the bending moment is 0, or technically I can say it is the point where bending moment changing its nature. Nature means from sagging to hogging, from positive to negative, from concavity to convexity. So all these terms, all these are the different ways of defining that particular point, which is point of contraflexure, which I can say the inflection point. Okay. I hope it is clear. These are the small terms which we have to take care when we are doing the problems related to shear force and bending moment. Okay. Now, again and again I am talking about the shear force diagram and bending moment diagram. What basically it is? Nothing. The diagram which shows the variation of shear force. क्या shear force क्या constant होगा पूरी beam में? No, it will not be. Definitely, if the loading is changing according to the length, the shear force value will be different. So the diagram which is showing the variation of shear force along the length of the beam is called the shear force diagram. Similarly, I can say about the same thing about the bending moment diagram. The diagram which shows the variation of bending moment along the length of the beam is called the bending moment diagram. Okay, clear? Now I am coming to very important point. Okay, variation of shear force and bending moment. Variation of shear force and bending moment for various different types of loads. Okay, the table is already available here. But how we are getting this particular, because या तो कोई इसको याद कर ले कि for this particular type of loading condition, this will be the nature of shear force, this will be the variation of shear force according to the horizontal line or inclined line, or we are able to write the equation. So let me come to the pure mathematics. Okay, suppose one by one I am taking the loading condition. First I am considering a point load condition. Okay, very important one. बहुत ही सिंपल सी बीम ड्रॉ कर रहा हूं, नथिंग एल्स. Okay, these are the different A and B. This is W Newton. If the distances are same, A, so what it will be? The reaction force will be 3W by 2 and 3W by 2. Just take a section here. Just take a section here, which is at x distance from point A. Which is at x distance from point A. Okay, clear? Now, shear force. Shear force at section which is at x distance. Which is at x distance. According to our definition, what it is? It is the algebraic sum of all the forces acting either side of the section plane. So I am just considering the left side of the section plane. What are the forces? 3W by 2 and W. 3W by 2 I am taking positive because it is on the left side, upward, and W I am taking negative because on the left side it is downward. I am considering only these two because according to our discussion, according to our analysis, shear force on the one side या तो left side लूंगा या right side लूंगा. So 3W by 2 minus W. What it will be? 3W by 2 minus W. How much it will be? How much it will be? W by 2. Shear force at x. What is the type of equation? If I am considering shear force as y, so this is constant. Y equal to constant. It means the line will be horizontal, parallel to the reference. Is it okay? Clear? कोई issue नहीं? Y equal to constant. Now I am writing the bending moment equation. Bending moment at section x. How much it will be? 3W by 2 into x. 3W by 2 into x. Positive लूंगा because on the left side it is clockwise. From the W which is on the left side, दो लोड हैं तो दो ही मोमेंट होंगे. So W, how much it will be? How much it will be? X minus A, the distance of W. What we are observing here? If I am saying bending moment as Y, I am observing the equation is Y equal to mx plus C. Y equal to mx plus C. कैसी इक्वेशन हुई? इंक्लाइंड लाइन की. So what conclusion I can draw here? At a particular section of beam, if the beam is loaded by a point load only, if we are observing the effect of point loads only, then the shear force diagram will be a constant horizontal line and the bending moment diagram will be a inclined line. So that's what is here. That's what is available here. Okay. Shear force diagram when between point loads or no load region. Okay, so it will be a horizontal line and inclined line. Now I am coming to the next one. Okay, first case is clear. Now I am coming to the second one. Second is UDL. UDL में किस तरीके का होगा भाई? shear force and bending moment diagram. That's what I am taking. I am considering a simply supported beam subjected to uniformly distributed load of W Newton per meter intensity for length L. ठीक है भाई, इतनी बात क्लियर है, इतनी बात में कोई दिक्कत नहीं है. At a distance x, okay, this is point A, this is point B. So the support reaction will be WL by 2 Newton and WL by 2 Newton. Okay, let's start writing the equation. ये तो हमारा point load के लिए हो गया था ये सारा. Okay, now I am coming to the UDL. What it will be? Shear force at section X. So on the left side, what are the different forces? What are the different forces? One, this is the WL by 2. Upward है positive and this much of UDL. डाउनवर्ड होगा, इतना UDL को मैं कंसीडर करूंगा. लेंथ कितनी है? इट इज x. इंटेंसिटी कितनी है? W. ऑन द लेफ्ट साइड इट इज डाउनवर्ड, सो माइनस W इंटू एक्स. माइनस W इंटू एक्स. सो shear force, if shear force को मैं लूं y, now you can observe the equation is y equal to mx plus c. Inclined line equation. Okay. Bending moment, now I am writing. Bending moment equation I am writing. At this particular section, bending moment, algebraic sum of all the moments acting either side of the section plane. So there are two loads, WL by 2 and WX. मैं बिल्कुल ऐसे ही चलता हूँ, जितने shear force के इक्वेशन में लोड लिखे हुए हैं उतने ही मोमेंट कंपोनेंट्स होंगे जब बेंडिंग मोमेंट इक्वेशन लिखूंगा मैं. सो बिकॉज ऑफ WL by 2, WL by 2, the distance from the section plane, कहाँ ले रहे हैं मोमेंट? सेक्शन प्लेन पर. सो द डिस्टेंस बिटवीन WL by 2 and x and the section is WL by 2x. clockwise है, on the left side positive. Then I am coming to this WX. This is what the load, where it will be effective. If I am considering only this, it will be effective at the midpoint. How far it will be from the section plane? It will be x by 2 because it is effective at the midpoint. So WX into x by 2. Clockwise or anti-clockwise? It will be anti-clockwise on the left side. So that's why it is negative. What I am observing here, the equation is something like this: WL by 2 into x minus WX square by 2. Parabolic equation, x square की term है यहाँ पर. So the parabolic equation, the curve will be parabolic. Bending moment curve will be opening upward or opening downward, that we will see according to the nature. Okay, that we will see. So it is clear. It is clear up to this point. Whenever a beam is subjected to point load in a particular section, then it will be a inclined line, and whenever a beam is subjected to UDL, the shear force diagram will be inclined line, and the bending moment diagram will be what? The parabolic. And point load के case में the shear force diagram will be constant horizontal line and the bending moment diagram will be inclined line. Let me erase this. 2-3 minutes I will take more. Okay, इतनी बात यदि clear है, because I don't want to leave this particular topic in between, so please bear with me for 2-3 more minutes. Let me complete this particular. For UBL, one more case I am taking, then I am leaving the class. Okay. Okay. The third case. The third one is, sorry, let me take the pen and color this. The beam is subjected to UBL. Okay, support reaction निकाल सकते हैं क्या? Support reactions will be how much? I hope निकाल सकते हैं आप लोग. मैं सीधा लिख रहा हूँ WL/6 and it will be WL/3 Newton. ठीक है ना? Please check. At a x distance, I have taken a section. Shear force at section x. Algebraic sum of all the forces on the left side. So WL/6 positive minus this much of UBL. कहाँ से कहाँ तक? The portion which I am hatching here. Okay. मैं इसको अभी y लिख रहा हूँ. What can I write here? Or bending moment at x. This will be WL/6 into x minus, now let me find out this load. For finding out this particular load, I will be using the property of similar triangle. This is x, this is y. कहाँ से कहाँ तक का लिया है मैंने? इस पॉइंट से लेके सेक्शन प्लेन तक का x डिस्टेंस पर y, और ये मैंने पूरा ट्राइंगल ले लिया L and W. So what can I write? Y upon x equal to W by L. And for treating the what? UBL, what can I write here? Area WL/6 minus area of the triangle, half into x into y, and at place of y, WX/L. For the bending moment, WL/6 into x clockwise positive minus load कितना है भाई? half into x into WX/L. This is what the load. Okay, it will be effective where? This will be effective at 2x/3 and x/3. Moment कहाँ ले रहा हूँ मैं? This is the position. This is x/3. This is 2x/3. Moment कहाँ लेना है? At the section plane. So I will be multiplying it with x/3. Now what we are observing कि जैसे ही हमारा लोड UBL हुआ, shear force is x square, parabolic equation. Bending moment is cubic parabola, x cube. Okay, I hope it is clear. This is the simplest way to find out the load. Okay, so for point load, for okay, let me erase कैसे होगा भाई? Am I बार बार वही आ जाता है. So I am erasing this. Cleared all the necessary points related to this. Now I am showing the table, which is the summary of the discussion which I made here on the board. Okay, so you can okay. What it is? Shear force diagram. कैसा nature होगा? When the load point loads are there, horizontal line, okay. Bending moment कैसा होगा? Inclined line, already discussed. With the UDL, shear force diagram, inclined line, bending moment 2-degree parabola. UBL, it will be 2-degree parabola. What? Shear force diagram, and the bending moment will be the cubic parabola. So I hope you people have understood the things. What is basically the shear force? What is basically the bending moment? How to find out the shear force and bending moment at a particular section, either on the left or on the right side, and the sign convention for shear force and bending moment, the relation between shear force, bending moment, and for drawing the shear force and bending moment diagram, this particular table. Because without knowing these facts, you will not be able to understand about SFD and BMD. In my next lecture, I will be taking what? I will be taking the actual problems in which I will be applying all these things which I discussed. So this particular lecture is very important. I will be repeating all these things again and again while solving the question. Okay. So thank you very much for attending the lecture. Thank you.